Hello all. Welcome to the session on integration of Denodo with QUBZ application. QUBZ is an OLAP solution that enables businesses to operationalize analytics on their big data platforms. QUBZ is directly integrated with Denodo, and the data from the Denodo platform is synchronized and made available in QUBZ. This video showcases the integration between Denodo and QUBZ, covering the creation of projects, configuration of the connection to Denodo as a data source, designing a model, defining and building an OLAP cube, and then running our insights against our created cube. First, open your preferred web browser and type the QUBZ URL in the address bar to access the QUBZ login screen. Type the username and password of the user here. Click Login. This opens the QUBZ homepage. The overview screen provides information about the user and lists the various functionalities available to that user. Click Projects in the left panel or in the overview screen to navigate to the project screen. Click New Project and create a new project. Say Retail Demo Project. The next step is to configure and sync a Denodo's data source for this project. Click on the project for which the Denodo data source needs to be configured and synced. Click on Data Sources. Click Configure Sources. This displays the Configure Virtual Source screen. Select the data source to be configured for the project from the data source type drop-down list. Here, I'm going to select Denodo. Please note that only one virtual data source may be connected to a project in QUBZ at a single moment. Type the host name of the Denodo data source in the hostname field. Type the port number in the port field. Type the name of the user who would have full privileges to the Denodo data source in the username field. Type the password of the user in the password field. Type the default database applicable for the data source in default database field. The test connection button is enabled only when all the mandatory configuration details are specified. Click Test Connection to test if the specified configuration details for the virtual data source are valid. The Save button is enabled only after the testing of the configuration is successful. Click Save to save the configuration details. The Sync button is enabled only after successfully saving the configuration details. Click Sync to synchronize the data. This displays a warning message that once the data source sync is successfully completed, the data source configuration for the project cannot be modified. Click Yes to synchronize the data. The data source that has been synced with QUBZ now appears in the Sources block. If the Configure Virtual Source screen is accessed again for the same project, then the screen appears disabled like this. Users can click Sync to synchronize the data in the data source with QUBZ at any point. To view the tables under a database, click on this icon. To view the columns inside the database table, click on this icon. To view the extended information of the columns in the database table, click on the Extend Information tab. To view the snapshot of the database table, click on the Snapshot tab. After successfully configuring data sources for the project, you now have the ability to design models on which your cubes will be defined. The data model can either be a star schema or a snowflake schema. One data model can be referenced by multiple cubes as well. To design a model for a cube, Click Models on the left panel to navigate to the model screen. You can design your models through a wizard or visually by using the Visual Model option. For now, let's select the Visual Model option. All the data sources available for the project appear in the Sources block. Drag the required database table to be added as the primary fact table for the model to the canvas. This displays the Add New Table dialog box. Select the dimensions required for the table in the model by clicking on the Dimension button of the columns. Select the measures required for the table in the model by clicking on the Measure button of the columns. If a column need not be included as a dimension or measure, then click on the Off button of the corresponding column. Click Insert. This inserts the selected primary fact table in the canvas of the visual model screen. To add a lookup table, drag the required database table to be added as that lookup table for the model to the canvas. Select the dimensions required for the table. Click Insert. This inserts the selected lookup table in the canvas of the visual model screen. Drag and adjust the lookup tables and the fact table in the canvas. Click on the column of the fact table and drag the arrow to the required column of the lookup table as shown. Once the arrow is connected, the Join Condition dialog box appears. Select either the Inner Join or Left Join radio button in the Join Condition dialog box. Click OK to save the join condition. The joining condition appears in the arrow. It is possible to get a full view of the canvas and the tables added using this window in the top right corner of the visual model screen. You can also configure the partition date column block available at the bottom of the visual model screen. Here, we can define any partitions for any incremental data ingestion. In this case, we are not defining any partitions, and this block can be skipped. Click Save to save the visual model details. Type the name of the visual model to be created. Click Save to save the model details, and the created model appears in the model screen. Now that we have designed a visual model for the project, we can go ahead and start defining our cubes. Click Cubes on the left panel to navigate to the cube screen. To create a new cube for the project, click New Cube. In the Cube Info tab, select the model based on which the cube must be created. All models created for the project appear here. Type the unique name of the cube in the Cube Name field. Type the email addresses to which notifications on the cube must be sent in the Notification Email List field separated by commas. Select the events occurring on the cube based on which notifications must be sent. Type a meaningful description of the cube in the Description field. Click Next. This displays the Dimensions tab. The Dimensions tab allows users to select the columns that would be used as dimensions in the cubes. Please note that it is mandatory to specify at least one dimension for a cube. Click Add Dimensions to add dimensions to the cube. All the fact and lookup tables added to the selected model appear in the dialog box. Select the columns required in the cube to be created from the fact table and lookup table blocks. Multiple columns can be selected from the fact table and lookup table blocks by selecting this icon. Click Save to save the selected dimensions. Click Next. This displays the Measures tab. In the Measures tab, Users can add columns based on which data aggregations need to be performed for the cube. The measure column can only be taken from the fact table. Click Add Measure to add measures to the cube. Type the name of the measure to be added for the cube in the name field. We will create a sales measure. Select the expression corresponding to the measure from the expression field. We will create a sum measure. Select the type of parameter for the measure from the param type field. It can be either a value based on a column of the fact table or a constant value. If a constant is selected, then type the constant value in the text box field. If column is selected, then you can select the required column from the param value field. Here we will select the column. Click Save to save the measures. Click Next. This displays the Refresh Setting tab. Refresh Settings tab is applicable if we are doing an incremental build for cubes, and it is based out of the partitioning data. Since we are not partitioning our cube for this scenario, we could skip this and click Next. This takes you to the Advanced Settings tab. The Advanced Setting tab contains a lot of different options to optimize our cube build. In the Cube Engine block, you can select the engine to be used for building the cube. Here we can use MapReduce to build our cube. Click Next. This displays the Overview tab with a summary of the cube we just created. Click Save to save the cube details. On successfully saving the details, the cube appears in the screen. A cube can only be utilized when the build is successful and completed. Once the cube is successfully created, the next step is to build the cube. By default, upon cube creation, Disabled appears in the status field of the cube. A cube can only be utilized when built successfully and made ready for use. To build a normal cube, click on the build icon. Once the cube is built successfully, then the cube automatically becomes enabled and the status changes to ready. To check the status of the cube, click on Jobs on the left panel. The Progress field displays the progress made on the cube building process. The initial status of the job will be pending as the job is still in progress. To view stepwise details of the cube building process, you can click on the Expand Steps panel icon. In case any errors occurred during execution of a job, then the step in which the error has occurred can be analyzed in the stepwise details. After analyzing and fixing the error, the job can be executed again and the cube can be built successfully. Now you can see that the job is completed successfully. The progress field shows a value of 100% and the status changes to finished. After successfully building the cubes for the project, we can run queries and get results with a very quick response time using the Insight screen. To run and view the results of a query, type the required query in the New Query tab. Here, I will run one of our saved queries. Click Submit. The query is executed based on the active cubes created in the results block. Now, as you can see, we have the results from the cube we just built. And it took sub-seconds to reflect the data. The successful results are displayed with this tick icon and status as success. The failed results are displayed with a cross icon and the status as failed. The reason for failure is also detailed. It is possible to run more queries as well. New tabs are opened incrementally for the new query submitted. To represent the data displayed in a graphical manner, click on this icon. The query results can be displayed in the form of line charts, bar charts, as well as pie charts. Select the required dimensions and metrics based on which of the charts need to be generated. To change the graphical representation of the data displayed to a table format, click this icon. To download the displayed data to a CSV file format, click on the download icon. The file is generated and saved in the Downloads folder of your desktop. Cubes can also be connected with other data visualization tools, such as Tableau, Power BI, and use MDX. With this, we come to the end of our session. Thanks for watching.